All right. I'd like to welcome you all to the NESTA Earth and Space Education Hour. This is a new seminar webinar process that we've been doing here. It is allowing us to share resources and other information with people, and it's been something that's been very, very good. So tonight we're going to look at NASA Earth data with my NASA data. Do any of y'all use this, or have you used the Earth data with my NASA data? Because if you have not, you're going to be in for a really nice surprise. I'm excited about it. And I know most of you are members. Again, these are benefits that we have with our community here at NESTA. We're going to continue to try to work those out so we can do them. I'm going to escape out for just a second with my stop sharing with this guy. I'm going to go back into a smaller thing here. And kick that out for just a second while I transfer something over where I can see it. This is the luxury of doing things this way. So what we want to let you all know about is, and I'm going to pop back in with the slideshow. NASA, this data website is for K through 12 educators and their students. The data, my NASA data provides accessible and usable authentic NASA Earth data and includes scaffolded resources which incorporate the data sets. They range from bell ringers all the way up to visualization tools for the data. And the webinar will give you a chance to learn about and explore the data and lessons available on the website. And of course, we will have a Q&A. Our presenter is Angie Rizzi, our very own Angie Rizzi. She is a NESTA Director-at-Large. She joined the My NASA data team in 2018. She has taught for over 11 years and is a seasoned Globe teacher. Angie also has over 10 years of experience as an IT consultant, which she leveraged to effectively utilize technology in her classroom. She mentors student investigations in air quality and has been part of the webinar series, Investigating Globe Air Quality, from the ground to the clouds to the satellites. And so I'm going to back out of mine and I'm going to put Angie into her lead with things.
Thank you. Can you see my screen?
Yes.
Great.
I believe we can.
So thank you for that introduction. I'm the task lead for My NASA Data, which is a great pleasure because I'm sort of able to blend that technology background with my teaching experience as well. And so, what we really try to do is to share NASA Earth science data and assets for the classroom. Really, we're mostly grade 3 through 12, and we do have some people in the undergraduate levels who use our resources as well. So we curate the resources from NASA. Sometimes it's a video, a visualization, all the way up to data sets and our own data visualization tool. So you can think of it as fully curated resources, which would be our classroom ready content, mini lessons, lesson plans, and interactives, which include 5E story maps. And I'll go through some examples of those. And then we have a flexible resource, which is our data literacy cubes. And that is something that can be used with students to help them learn to interpret earth science data in the form of mapped data or time series graphs or data tables, all of which can be obtained in our inquiry-based Earth System Data Explorer tool. And then we have resources to help make connections So we have our subject matter expert STEM career connections, as well as connections to the Globe program. If anybody here is familiar with that, it's certainly not something that you have to use with my NASA data, but you can, and it's complimentary. The website, I just have this slide here. Um, we organize it by what we call phenomena. You can think of them as topics. They're not always as specific as you might think of as a phenomenon based lesson for NGSS standards, but we have a wide variety of topics. And because we organize this by Earth system sphere, so you see these little icons on the screen. The circle with the cloud represents atmosphere. The leaf is biosphere. The snowflake is cryosphere. The volcano, geosphere, hydrosphere, drop, and Earth as a system. It's a picture of the Earth. Because we have things organized by Earth system sphere, you can imagine that these phenomena or these topics, they can be applicable to more than one sphere. Okay. But they typically live under one on the website. When you pull up a phenomenon, so here we hover over atmosphere on the main page, we select urban heat islands, and you will see the three main types of content on the page. Okay. And so I'm going to hop out of here and go to the website and just try to demonstrate this live rather than having static slides. So if I hover over atmosphere, I click on urban heat islands, which is a very popular group of resources that we have. You will see some information about that will pop up. You can click on read more, and there's a whole information page about the topic. Okay. I just went back, and it's going to default to listing the mini lessons. There's a rotator, but it won't have all the content, and all the content will be listed below. And so these mini lessons are short, student-facing content, and you can link it to Google Classroom if you have that. So in this example, there's one graphic. They have 5 questions with a couple of parts to answer, and that's all it is. Okay. So this graphic here has a lot in it. It's got different types of development. It's got day and nighttime surface skin temperature as well as air temperature. And then you notice here over water, there's something interesting going on. So you can sort of focus on what you want to focus on with that too. And if you want different questions, you can just use the graphic and have your own questions. But that's a mini lesson. They're short. They're designed to be something that I wanted a lot when I was in the classroom, which is like, I need a little piece to complement what I'm already doing. I don't need somebody to tell me my entire unit, right? I just need a little extra something. That's what the mini lessons are designed to be. The interactives are also student facing, pardon me, and they are designed to be something that the students get to digitally interact with. A lot of them are GIS story maps. So this one in particular, I will tell you right now, it's only for Austin, Texas. I'm sorry. Everybody always is like, but I want to see my area now. And the data sets are so big that we can't load them all. But
Just another, I was gonna say, just another question about that. Is that because we have that center over at Pickle Research that downloads a lot of the satellite data
I don't know anything
of
about
the
that.
University of Texas? Yeah.
No, we picked Austin because Austin is a good example of something where the land cover classification has changed a lot due to the rapid development.
Mm. interesting to know. Thank you.
Yeah. Thank you for that. So they're just getting used to the surface skin temperature here. Then they scroll down and they can look at the land cover classification and the temperature and pay special attention to our legends because sometimes yellow is a hotter color than the pink and red tones, hotter color, hotter temperature. So you can they can start to see some patterns going on, and there's a little bit more to this, but the point is this is something that they can digitally interact with. Okay, so that would be an interactive. Beyond that, we have some like interactives that are maybe on steroids, I guess, uh, which are called story maps. And the story maps are written in a 5E model. So they have the engage, explore, explain, elaborate, and evaluate. And they're going to be much longer. They're still student facing, but they are going to take some time to get through, at least 90 minutes, if not longer. And they go through each section, and there are opportunities for them to interact with data. This is some student collected data from the GLOBE program. Um, so they start looking at things like the type of surface, whether it's natural or man-made. Um, and they go through a whole bunch, and I don't want to spend the whole time going through this story map, but you can see that it's organized. And then just give this one example here where they can sort of use a tool and see what's going on and explore. And then by the time they get to the end, they are making a plan for watching a, the Peachtree Road race in Atlanta, Georgia, and trying to figure out where should they stand, and then designing an experiment for different colors of rooftops. We've had a lot of teachers who use this story map as a launching pad and then really take that design and experiment part a lot further than we do and have their students like build models and conduct the experiments and present to the school board on what they might like to do with their school to make it cooler and things like that. But that's up to the teacher who's implementing it. In fact, we have a publication that will be coming out about that soon. So those are interactive. So we have shorter ones and then we have the long story maps. Any questions on that before I move on? So I covered two content types, mini lessons and interactives.
Um,
The grade bands I'm seeing are noted in the content. There's also a search feature. And if you go into the search feature, okay, apparently it's not working right now. Oh, there it is. It's just slow. You can also filter by grade band. It's a good question. And I'm not seeing anything else. So, okay. So the lesson plans, it's more what you think of as a lesson plan. We've tried to write the whole thing out. You can download them as a PDF. They're going to be more of a full-blown lesson, and we do have some where there's like maybe a hands-on experiment that they do, or maybe we have some different visualizations embedded in it, as well as there's a claim evidence reasoning in this one. I mean, each lesson plan is a little bit different. And at the bottom, you'll see things that you can open up, like the learning objectives, the essential questions, the three-dimensional learning components, um, why does NASA study it, that type of thing. So this is all where we've tried to take the resources and curate them for you and come up with what we think are some reasonable questions. Of course, like most teachers, modify everything that they get a little bit to meet their group or their needs, and we certainly expect that. Um, and so then the next level is actually using our data literacy cubes. And the data literacy cubes are designed to be used with either a map or a graph or a data set, like I said before. So there is a basic template where you can build a cube that looks like this. Okay. And it doesn't matter whether you're using a map or a time series graph or you have a data table, you kind of use the same cube. And if you're like me and I had like 6 preps a year, I didn't even want to put the cubes together. We just numbered the questions so that you could use dice, right? And then there are question sheets that go along with either the maps or the graphs or the times or the data tables, and they are leveled novice, developing, proficient, and advanced, and they're leveled by the student's Lexile level and their WIDA proficiency level. Okay, now that being said, Lexile level of 2 to 400 does not necessarily mean that the questions are 100% appropriate for elementary students. It means that the middle and high school students are at that reading level, if that makes sense. Okay. Um, I'm scrolling through. There's your template. We do have this task card where we can group the students. This is particularly effective when we have students that are um, learning how to speak English because they have some duties that don't require them to be reading or writing. And so the questions, I love the graph questions. So I'm going to skip to the graph. So level 1 of the graph, this is novice, they have to know these key words in order to be able to understand the questions. Okay. So these are not like a word bank where you use them to fill in the blanks for the answers. These are words they need to understand to process the questions. So the level 1 talks about the horizontal and vertical axes. There's a labeled version followed by the exact same thing that is not labeled because some students pick up on that really quickly. Then we move to level 2 and it asks about the X and Y axis. Okay. Then we move to level 3 and it talks about the independent and dependent variable. Level 4, what variable is represented, what is the range, and it goes from there. So these cubes help them make sense of the data. Any questions on that?
No, but Angie, we do have a comment.
I see about
Yeah,
apes.
Michael, yeah, about apes, because we were just actually talking about that, you and I.
Yes. So I would have to check with my lead on that because we have tried very hard and we do have a lot of AP teachers that use our content, but we've also tried very hard to make sure that we are not only content for the AP level student, right? That we have content for all students. That said, we do have summer interns occasionally in the summer. Actually, we have for many years. I see a former intern on this call. Um, so it could be something that an intern could do for us one summer, and it is something that we have talked about in the past. Okay, so I just showed you the cubes. Oh, there's at least two of our former interns on this call. Um, so the cubes are great, and the cubes are sort of like this flexible resource that I referred to at the beginning, and they kind of can help bridge that fully curated content to, like, you can use your own map or your own graph, or the students can maybe even generate their own. But how can we do that? If you go and you hover over visualize data and click on that, you will come to a page about our data visualization tool, which we call the Earth System Data Explorer. Okay. We have questions and things like that. But if you click on this and access it, you're going to go into our Google Earth Engine based tool. Now, we used to have a wonderful tool that was actually at a tool that NOAA developed. Um, and we used that for like 20 some years. But eventually, as always happens with systems, NOAA about 2 years ago said that they were no longer able to support that. And so we developed a new tool based on Google Earth Engine. So again, like our content, it is organized by Earth system sphere. So you can select a sphere. I selected atmosphere, and I'm going to scroll down, and under the categories, I'm going to select temperatures. And then our most popular data set is monthly surface air temperature. Notice we have daily air temperature. Most of our data sets are monthly. We have a few that are daily. And the reason for that is because a lot of the daily satellite data will be missing areas if it is a polar orbiting satellite. So in order to sort of have a full coverage, monthly helps us fill in those data gaps, and that's helpful. We also, like the most current data that we have is going to be August of last year. So I'll pull up June since we're in June. So you're not going to be able to go and like look at the weather from today or yesterday, but you're going to be able to get a lot of information on historical data as well as normal ranges and boundaries of data and that type of thing. Okay. So here I have a graph. You can zoom in, you can get super local. You could type in your school and you will zoom in so much that you can just look at one pixel, right? But you can get really specific and then you can zoom out if you want. So you can find a location on there. It is pixelated data, right? So you do want to think about that. And remember what I said a few minutes ago about the legend? What's the hottest temperature color on this legend? Someone tell me.
Yellow.
Yes. Now, your students are not going to necessarily think that when they look at the maps. And this is what I'm talking about when I'm talking about using the cubes with a map. I'm talking about this type of data where the colors on the map represent the actual satellite observation data. Okay, so we have this. We have June of 2024, and I'm going to show you a few of the features that you can use in here. The first thing you can do is compare to swipe, and the students love it. And I'm going to pick the same monthly surface air temperature data, but I'm going to choose January of 2024 instead. And just like we saw the swipe tool in one of the interactives, we have it in our story maps, they can swipe and they can see the differences. They seem to love this, okay? That said, So I'm going to exit this tool. Now I could compare two different variables in here if I wanted. This is the same variable with two different time frames, but I could look at two completely different variables to see if there's any correlation or not. I can also change the color palette to grayscale on one or both sides. Okay. Which is very helpful when we have students that have visual issues or just for printing. Okay. So there's a lot of different combinations that you can do here in the compare to. There are some students that have difficulty with that compare to, because when you do the swipe, the other data sort of goes away, right? And you're looking at one or the other at the time. So we do have this side by side option as well. When you do side by side, you don't swipe, but you get the full image next to each other. So that sometimes is a lower cognitive load for some students. Okay, so we have two different ways to compare the visuals, and you can pop these out and then download these images or print them. Okay, so that's how you can get your own maps. And you can zoom in and you can get a regional map, or you can go even more local. Now, you saw the pixel size, right? If you go too local, you're just going to have one color. So you do need to think about that. Any questions on looking at the maps with this tool? Okay, I'm going to exit the side by side. The next thing you can do is identify, which is basically probing the data. So you can just click on a location. Sorry. Click on a location, it will tell you the value and it will tell you the latitude and longitude. And you can just click around, right? And you can find information. We're working on making that so you can build a table, but we're not there yet. So, but that can help you find the lat long for a location and the value for a location and explore the data and see what it means. We also have what is called a time plot. And again, I can just click on a location. It fills in the lat long for me. You can type it in if you want. I can create and select, well, I can select my time frame. And you can do the whole time that's available if you want. And I can also add a second variable if I want. Okay. So I have the monthly surface air temperature here. I'm going to go into the geosphere and pick the skin temperature and pick the daytime surface skin temperature, which is the actual temperature of the ground. And I'm going to generate a double line plot. Okay. Now this is saying that the surface air temperature is this dotted line and the surface skin temperature is this blue line. And what do we notice about the two axes? The two y-axes.
They're all set.
They are, right? So
And
occasionally when you do a double line plot like this, the graph, if the students don't have a good data literacy on reading the graphs, might look misleading. Because I could do a graph like this for daytime and nighttime surface skin temperature, and it might look like the nighttime is warmer because it's it has a lower range on its axis. Okay, so this is a great feature. And again, we can pop these out and we can download these images. That's a great feature, but you might want to work with the data a little bit more, in which case you can use our data table feature. The data table feature, again, select a location. I'm gonna go crazy and go over here to Oregon. I don't know how close I am, but I'm trying. And I'm gonna pick a range. I'll just start at the beginning and grab a bunch of years here. And I can add up to 3 more variables. So it's the variable I'm looking at over here on the left, but I'm going to add 3 more variables here. So I've got the monthly surface air temperature, and I'm going to add the energy into the surface by shortwave radiation, because I think that might have something to do with temperature. And I'm going to go into the geosphere and pick skin temperature and choose the daytime skin temperature, and go into the geosphere and select the nighttime surface skin temperature, and I will generate my data table. You can do 1, 2, 3, or 4 variables. They'll all be for the same location. And you can see here what the table looks like. And if you expand it, oh, this is a great example. Apparently, we do not have data from 1980 for all these variables. So let me go back and see if I can change the date range without having to select everything again. It's actually good that it didn't give an error. Okay, so we have all 4 variables here. If you have missing data, it's not going to fill it in, right? I'm waiting. I'm patiently waiting. And suddenly this download CSV button popped up. When I click on that, it's going to prompt me to download the CSV file. And then you could take that and you can take it into a different tool like CodeApp. You can use it in a spreadsheet. You can do whatever you want. I like to download temperature and precipitation data for 30 years because we do have both for that time frame, and then make climate graphs for individual locations. So I'm going to stop there. I'm going to exit the data table, and I want to see if anybody has any questions. I see Elaine put the link to the website. Thank you very much. And I just put a direct link to this visualization tool. If anybody wants to get in there, and I can do a couple of things at this point, and I want to be somewhat conversational. I could, if you have questions about a specific phenomenon, we could go down that route, or if you wanted to try out the tool, and I can be here and help out and answer questions, I'm available for that as well. And I see that Diane put a comment that her students really loved working with Urban Heat Island. How often are the data updated? That is a great question, and it is as often as NASA releases the data. So what we do is what we try to put out level 3 globally gridded data. We just made sure all of our data sets last month were as current as we could get them. So we try to look at it every month or two, but we also have to wait for the scientists to release the new data. And then we do have, like, you saw we had a little missing data like back in 1980 for some of those things. Those missions probably didn't start until after 1980. Um, so not every data set that we have has exactly the same date range, because sometimes the mission hasn't started yet, sometimes the missions end. So we have different date ranges. We do have we have this data set citations page where we actually have like the sources of every data set. And then the data collections page tells us all the data sets and what the date ranges are for availability. So I'm seeing here we have one thing that's even up to May of 2025, which is amazing. Anything else?
Yes, this is Mike Smith. I guess a question I have is like, what are the other mechanisms besides like this awesome NESTA webinar that you're using to get the word out to teachers about this program and this
That's
data?
that's a good question. So we go to conferences like NSTA. Um, we typically have one or two webinar series every year where we have it publicized through, have you heard of NASA Express?
Yeah.
They'll publicize it in NASA Express. Um, we do teacher professional development through like school systems or with space grant organizations. Um, we work
Well, I
with,
mentioned, I don't mean to interrupt. I mentioned apes. I also have taught AP biology for the
mhm,
last 15 years or so. And, HHMI has a really nice model where they kind of craft data analysis and activities for teachers, and they integrate it into like a lecture series. And then they have a whole mechanism of HHMI fellows. They get out and do workshops, and I've attended a number of those, sometimes at conferences, sometimes locally. Like I'm really fortunate to have an HHMI person, in the Cleveland area where I'm from. Um,
mhm.
it seems like that might be something to consider in terms of like making, um, a cadre of ambassadors, for this awesome data that you have. Just want to throw
Yes,
that out there. So,
we are working on that actually, and we've been working on it for a couple of summers now, and what we we're learning a lot about it, and
uh-huh.
we definitely have a couple different avenues that we're exploring. So there's sort of different levels of expertise that people have with our site, right? And because you can see there's so many pieces and parts to it.
Yeah.
Um, but yes, that is something that we have thought about, and we are sort of refining a plan on that. So I'm glad to hear that there's people out there that would be receptive to that.
Yeah, I think there would. Thank you.
Thank you.
I was going through the hydrosphere and I noticed that several of the lessons in there will be really good for our aquatic science. They tick quite a few of our standards that we have to do here in Texas. And
That's
again,
good.
from the ape side of things, I really am glad about that. And also the differentiation that you've included. That's a great resource for all of us that are still teaching in the classroom.
Yeah, that was something when I taught in a middle school. I did all the science in the whole middle school and all the students, right? It was a small school. But in 8th grade, they had the option of taking earth science for 8th graders or earth
Mm-hmm.
science for high school credit.
Mm-hmm.
And I had to teach both of those classes during the same class period. So I definitely had to differentiate everything I did. Not just for individual student needs, but for the actual class that they were taking. um, so that is something I definitely brought to this team. Um, anyhow, anything else?
Well, I guess I have one more thing. You mentioned the team. So can you just describe the team that works on this in terms of getting it out to teachers?
Oh, absolutely. And this would be a great thing for you to talk to students about. Um, I mean, you heard a little about my background, right? I manage the website and the development and everything, but I also have that educational background. So we have two additional professionals who are part-time on the team who help us also with educational content and are former teachers, um, definitely with earth science backgrounds. So they bring that educational lens and they can help with that sort of curated content part of the site. But then we also have a full-time scientific programmer who is the one who developed the complete visualization tool. Um, so that is her responsibility, and she keeps the data up to date and she makes all the enhancements. So there's one person who is responsible for all of the code behind this visualization tool. And then we have another person who is our website IT person who works on that as well as helping with developing some of the GIS story maps. So that's our
We
team.
we have yeah, thank you. We have a question in the deal on the chat. Will additional phenomenon be added over time?
Yes, we are getting ready to add, but in August, a space weather phenomenon. Um, and then we'll see what additional priorities are set. Sometimes those priorities are set outside our team, but we added a solar eclipse phenomenon before the eclipses in October of 23 and April of 24. And we had over a year's worth of activity in 1 month around the total solar eclipse last April. Um, so that was very busy time for us. And we're doing space weather now. So I think we might have some additional content related to that. And then we have to decide what comes next.
Seems like I guess this is the apes teacher in me speaking again, but something with wildfires.
Wildfires, I would love that.
Mhm.
Um, we have a whole list of phenomena, and that is on our list. We just have to see how the priorities shake out. That's an area that I'm based at NASA Langley Research Center, and that is an area that a lot of the scientists at NASA Langley work on. And I failed to mention earlier that I was also a teacher intern for this team before I got this job. And when I was a teacher intern, I worked with my students on air quality, and that is just an area that is near and dear to my heart. But there's also a lot of data related to that. So,
Yeah, if students could have the opportunity to look at how that changes over time, because people hear on the news climate change is causing things to become more intense and more frequent. But if they had a visualization tool to see that, I think it would be very powerful.
the other thing I really like about that is that there are far-reaching effects. So you
Yeah,
might not have any burning in your area, but you very well may have air quality impacts where you live. I mean, it, we can get air quality impacts from wildfires in California all the way over in Europe. So it's a reason for everybody to care. We do have an air quality phenomenon, and it does have some things about fires in it already.
great.
Yep. Another thing I would like to mention, if any of you cover Earth's energy budget, the Earth's energy budget story map. So if I go under Earth as a system and I go under Earth's energy budget, under the interactives, and I go into this story map, then I have to click out to the GIS version of it. In the Explore section, we build out the energy budget diagram one arrow at a time. And then we have like visualizations that show what that arrow is. And then we start looking at the next part. And I do really like this, and we have gotten a lot of very good feedback on this. So this shows you in the diagram what the visualization is showing as it gets more complex. And we go through and watch your eyeballs. I'll scroll all the way down till you have this full diagram here. In this explore section, they basically kind of discover that it's out of balance, and then we go through in the other sections and talk about what's happening. We talk about greenhouse gases. And then in the elaborate, it talks about how clouds can have a cooling effect or a warming effect depending on the type of cloud, and aerosols, relating back to air quality, can also have a cooling or a warming effect depending on the type of aerosol. And so then in the evaluate, they have to make a claim about why it's out of balance, citing evidence, right? This is something that I really like, because if you put the diagram in front of them and then they try to balance it, and we have versions with numbers and without numbers and all kinds of stuff, and they try to look at all the numbers, it's crazy. So
Any other questions from anybody or any thoughts on some things? Is there anything else you want to share, Angie?
nothing specific. I mean, I could go on all night, but I encourage people to go in and explore. I also do want to put my email in the chat. Because if you have a question, I'm very happy to answer. I know there are people on this call that have worked with me before and know that I will respond. Maybe you can vouch for me. Um, I will help. And I mean, that's really what we're here to do, is to help you get NASA data and NASA resources into your classrooms.
you. I appreciate it. We've got a few more minutes that we can hang in here with. I do want to let everybody know that, as according to what I know, we do have at least 2 more of these webinars. I believe, Diane, I think you're doing the one in August.
I
Is that
think we
correct?
switched. I think we switched that over to David Curry. He's going to be sharing something
Okay.
on, I believe, argumentation. So really looking forward to that one.
Is that the one for August the 11th? For August?
Yeah, if there should be it should be on that slide deck that I shared with you.
Okay, well, I'll take a look. I'll pop that back up. And then one other thing I'm going to put into the chat. Artist Harold, who does most of this, and has set this up. She has let, in case you have not known, June the 23rd, they're going to be doing a Rubin first look. So I'm going to put in information about that's coming up on June the 23rd with the Rubin Observatory. And there's also another exploration from sky to classroom on Monday the 30th. But these are some webinars, and so I'll stick them into the chat that Artis is doing, and there you go, so that we have those out there. Oops. Let's see if it's going to come up for y'all. It may be too much data. It may be too much. I'll see. I'll get it out to y'all. I can also send it to you by email, and we'll have an advertisement probably on the NESTA site. So let me take this out and see if I can get it to come up. Oh, yeah, I try. Okay. Is there anything else that we'd like to talk about or ask? Any questions on things? There we go. There's the Rubin First Look. It's a 1-hour webinar that will be happening. And let's see, then there's another from Sky to Classroom. This is another thing that's coming up. Good question, Don. Most of we have this information about the webinars is on our homepage for the NESTA website. Let me pull it up here and I can show you. Let me go into the public view and I'll pop you up here. So Diane, I'm gonna let's see, share. So we have this information on our NESTA website, which is at nestanet.org. And if you scroll down, it shows across our banner that changes occasionally. Then as you scroll down, NESTA presents Earth and Space Education Hour. This is the one we just did, and this is where you can register for it. And that's where you'll be seeing the other ones coming up. And as they come live, we'll put them up over there. And this is again on the home page. All right. Does that answer the question? Let's see, pull up the chat. Bye, Bruce. If we are done, I want to thank you all for being here and being part of this webinar. I've found that the ones that preceded this have been really informative, and this one's been really helpful. I'm really excited to take this information to the APC training that I'm going to be going to in about 4 weeks, 3 or 4 weeks, and also to share it with my district, with my aquatic science and some of my other courses in the science department for the district here in Austin. I want to thank everybody for attending. And we will be, those of you that have requested a certificate, we'll be getting those out fairly soon. It may be a week or 2, we'll see, but they should be coming out soon. So thank you very much for attending. I hope you all have a very lovely evening. And we'll see you at the next one. Thank you,
Thank
Angie.
you.
Woo, yay.
Thanks, Angie.
Thank
Great
you.
job. Hi, Diane.
Hi.
Thank you.
Bye.
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 Okay.
Thanks,
We
Angie.
are
Thanks, Elaine.
Thank you.
done.
Have a great night.
Have a good night. Bye.